Let's talk now about composite functions. Composite functions occur when one function is plugged into another function. The following are common notations used for composite functions. F with an open circle g of x means f of g of x. This means we are taking the function g of x and plugging it into the function f of x. Again, the way that we say this is f of g of x. The domain of the composite function f of g of x is the values of x in the domain of g such that g of x is in the domain of f. Now, that's a little bit confusing. Let's see if we can simplify it a little bit. All right, when finding the domain of a composite function, determine the intersection, that's the overlap, of the domain of the inside function and the domain of the composition as a whole. So there are two different things you're going to have to look at the domain for. Start with the domain of the inside function, then find the domain of the composition together. Let's go through a couple examples here. Given the function f of x equals x squared plus 1 and g of x is equal to root x plus 3, find the following and state the domain. In this case, they are asking us to find g of f of x. Again, make note, the open circle, this means of. It does not mean multiplication. This is not g times f. This is g of f of x. This means we are taking the function f of x and we are plugging it into the function g. So I always start off by writing that down, g of f of x. Now we can begin to replace some things. Let's think about order of operations. We want to start from the inside out. Well, f of x, what's f of x equal to? F of x is equal to x squared plus 1. So the first step is to simply replace f of x with x squared plus 1. Next, we need to evaluate g of x squared. That means for my function g, wherever I see an x, I'm going to replace it with an x squared plus 1. This gives me the square root of parentheses. And again, guys, whenever you go to plug something in, get in the habit of putting it in parentheses. What are we plugging in? We're plugging in an x squared plus 1. And where are we plugging it in? Wherever we see an x in this function g. So we get x squared plus 1 plus 3. So is there any algebra that we can do to simplify? Sure, x squared plus 1 plus 3. That gives us x squared plus 4 inside of our radical. Our composite function f of g of x is equal to the square root of x squared plus 4. Notice, do not distribute this radical to both of our terms inside. All right, these are connected by addition. If our terms inside a radical are connected by addition or subtraction, you cannot apply it to both of the terms. This is as simplified as we get. All right, now let's talk about the domain. As we said before, to find the domain, we must analyze the domain of the inside function and the composition as a whole. Where they overlap will be our domain of our composite function. So let's look at our inside function first. All right, the inside function is f of x. Let's find the domain of x squared plus 1. Well, again, our two rules for finding domain, all right, are going to be the denominator of a fraction cannot equal 0, and the value inside of a square root must be greater than or equal to 0. Well, we don't have to worry about either of those cases here, which means that our domain of f of x is going to be all real numbers. Once we look at the domain of the inside function, we need to look at the domain of our composition as a whole. Again, no denominators to worry about being 0, but we do have a square root. We know that the value inside of the square root must be greater than or equal to 0. So turn that into a mathematical expression. Here we have the inequality. X squared plus 4, that's the value inside of the root, is greater than or equal to 0. Now, notice that trying to solve for this, you might end up with something like x squared is greater than or equal to negative 4, right? You could subtract the 4 over to the other side. Well, what happens when you square something? Whenever you square a number, it doesn't matter if it's positive or negative, you will always end up with a positive value. And even if we were to plug in 0 here, 0 squared is still greater than or equal to negative 4. This statement is actually always going to be true, right? If I take a number and I square it and I add 4, that's always going to be something that's greater than or equal to 0. Because the statement is always true, there are going to be no restrictions on the domain. Our domain for our composite function as a whole is going to be negative infinity to positive infinity. So looking at the domain of both of those, we need to find where they overlap. Well, where do they overlap? From negative infinity to positive infinity. There is the domain of our composite function. All right, same functions. Now let's find f of g of x. Again, open circle means of. This means we are taking the function g of x and plugging it into the function f of x. So first thing we write down is f of g of x. Now we can begin to replace a few things. Work from the inside out. What can I replace g of x with? Well, g of x is equal to the square root of x plus 3. There we have it. So now I have f of root x plus 3. To evaluate f of root x plus 3, I go to my function f of x, and every single x value, I am going to replace it with a root x plus 3. This becomes the square root of x plus 3. Notice, what did I do with it? I put it in parentheses because I'm plugging in that entire quantity wherever I see an x, squared plus 1. All right, let's do some algebra now to simplify. Well, you might recall that taking a square root and squaring, those are inverse operations of each other. That leaves us with x plus 3 plus 1, which gives us our final answer. F of g of x is equal to x plus 4. Now let's find the domain. To find the domain, we have to look at the domain of the inside function and the domain as a composition as a whole. Here's my inside function. G of x is equal to root x plus 3. What do we know about root x plus 3? Well, the value inside of a square root must be greater than or equal to 0. What's inside of the root? X plus 3. What does it have to be? Greater than or equal to 0. Solving for x tells us that x is greater than or equal to negative 3. Our domain for our inside function is going to be values of x that are greater than or equal to negative 3. Bracket negative 3, comma, infinity. Then we need to look at the domain of our composition as a whole. Well, I have no denominators here that I have to worry about being 0. I have no square roots. Therefore, I don't have to worry about either of our domain rules, which means that our domain for that would be negative infinity to positive infinity. So to find the domain of our composite function overall, we need to figure out where these two domains overlap. Well, where they overlap is going to be from negative 3 to positive infinity. All right, our domain is going to be bracket negative 3, comma, infinity. Okay, we have to look at the restrictions on the inside function first, and then any restrictions that we might have left over as a composition.